Hello all. So as part of this video, we will see one of the interesting topic, that is Google Cloud Dataflow. We'll try to create Google Cloud Dataflow pipeline using Apache Beam SQL. Right? This is one of the interesting topic. So let us see. Let us move to the next slide. Okay, as you all already know. So let me basically brief Apache Beam, what it is, then how we can create pipelines using Apache Beam, and how we can deploy those pipelines into uh, like uh, execution engines like Dataflow and other runners, right? So Apache Beam is an open source, uh, will be used to create Apache Beam pipelines using SDKs, software development kits. It's a unified programming model for batch and streaming data processing pipelines. We can create batch pipelines and also streaming pipelines using this model, right? So if you see this diagram, so let us go, right? So let us see this, try to understand in detail, right? What is this Apache Beam and how it can be used, right? First of all, we will try to see the use cases, like especially there are use cases like stream and batch analytics. If you have to apply some transformation like data enrichment and data cleansing on top of any data, right? And if you like to prepare some data for machine learning, right? And also in case of financial applications, right, to detect some anomalies, frauds. So you have to process the data, right, in stream or batch mode, right? In such use cases, we can use Apache Beam programming model to create pipelines, right? That can be run at different runners like Dataflow and Spark or Flink. There are many runners. So you create it once and you can, as per your convenience, you can run those pipelines on any other execution environments, as I already told, right? So Apache Beam SDK comes with different programming languages like Java, Python, Go, SQL, right? So as part of our previous videos, we have already seen how to create Apache Beam pipelines using Python. But as part of this video and demo, I would like to use SQL, Beam SQL, right? Okay. So this is a basic representation of a pipeline, right? So you will be having a source from where you extract the data, then you apply some transformation, and then you write the data into one of the sink, all right? So this is very much useful for real-time analytics, all right? And if you have to process huge amount of data, right? So this can be, I mean, this particular programming model can be run on any of the uh, highly scalable environment like Dataflow, Spark, right? And it's also cost effective. Okay, so this is how we can use Apache Beam to create pipelines, right? So let us move to the next one. Okay, so Apache Beam. So why we are interested in this particular thing, right? So we have seen like Python, Java, and SQL also widely used, right? uh, Database query language, we say, right? That structured query language in many of the database applications, right? So we may have so many people, uh, we may find so many people with this skill set. For them, right, this is definitely very much useful, right? So Apache Beam is providing even the SQL interface or SDK, right? So definitely you can even query p collections. You can apply some transformation using SQLs, whether it can be a bounded or unbounded, right? Unbounded means a streaming data, bounded means a batch data. So basically Beam SQL supports two different dialects, right? In case of big data processing use cases, by default Beam basically giving this calculated SQL dialect, right? So you can use that. If you have to work with BigQuery, especially in many of the use cases, especially in the GCP platform, So Jata SQL is widely used SQL dialect. This is completely compatible with the BigQuery, right? And there are two concepts we should know before going to the demo, especially when you work with, right, Beam SQL. We have to know these two concepts. One is SQL transformation. So this is an interface for creating P transformations using SQL queries, right? We will be using this interface as part of our pipeline. And the row is usually, right, when you use SQL for querying tabular form data, right? It should be in a row format, right? Here also, first of all, you have to use SQL transformation. You will be applying that SQL transformations on top of some row formatted data. That's why you have to basically convert the data into Beam row format, and then you will apply SQL transformation on top of it, right? These two concepts are very important, right? You can see, just try to understand the flow, right? You can see the diagram, right, in the flow, in the slide, right? It has been shown in the bottom of the slide, right? So that is the source, and then you will be reading the data into P collection, and then you can here there is one more concept, right? So you can always combine SQL transformation with other Python or Java uh, transformations in single pipe, right? So that's where you apply some other transformation, especially if you are not able to perform certain transformation using SQL, then definitely you can go for Python or Java, right? So you can even always combine SQL transformation with other transformation, right? And then you will, again, there will be one more P collection, then you will apply SQL transformation for grouping, right? uh, for windowing. There are so many functionalities available, right? And then you can write the resultant data into sync, right? Okay, now let's go to the demo to understand it in a better manner. Okay, uh, okay, I'm in my Google Cloud Platform project. So yeah, okay. First of all, so what I'm trying to do, let me explain that here, right? So this is my input data. Okay, I have just uploaded this input file. This is Beam SQL CSV into one of the GCS bucket in my current project. Now I would like to read the data into my Beam pipeline, Beam SQL pipeline, which will have both the transformation, like I'm using Python SDK over there, and also I'm applying SQL transformation and certain P collections. Okay, so this is my raw data or input data, where I have three columns like symbol, buyers and flag, and then quantity trader. So what I'll do in first step, I'll be using Python Purdue transformation to clean this data. First of all, what I'm trying to do is, I would like to, if you see, right, this quantity trader is a string and it has two quotes, right, enclosed with two quotes and also comma in between. So I would like to just trim those by using Purdue. Then it will be converted into a some basically a clean format, right? So where you don't have these quotes and then comma. Then I will try to convert that particular line, this particular line. Each line will be acting as a string in case of Purdue, and I'll convert that into a beam row. Then I will apply certain logic where, based on my flag, if it is a buy, then I will cast this particular uh, quantity traded to a positive number. If it is a sell, right, I will cast it to a negative number. Then I'll group that based on my symbol, and then I'll sum it. So this is my final P collection or final data, where I'll try to write the data into a BigQuery table. So this is what I'm trying to do, right? Now let us go to the code, actually, what I'm trying to do, right? So this is my code. Okay, so okay, so here it is, we have import statement. So as you know, now just try to understand this, right? I'm trying to import this SQL transformation module, right, from this Apache Beam transforms .sql, right? And then here I have Purdue transformation to clean, to perform the first step on top of that data, where I would like to trim those codes and then I would like to remove that comma, right? So this function or this class will do that. Okay, then I have my main method. So here I'm trying to read inputs from my command line, right, from Cloud Shell. When I try to submit this pipeline right through Cloud Shell, I'll be passing these inputs like project, region, right, other parameters. Then this is a SQL query, right, which I'll be applying this transformation. This is a SQL transformation, right, on top of peak collection, which is coming as a result of this transformation, right? You can see here, right, I have some the same whatever the thing I'm performing here, I just performing here also. Just ignore this for now, but here you just concentrate on this logic, whereby then convert it into a positive number. If it is a cell, then it is a negative number. Then group it and sum the quantity, right? So here is my pipeline. So my pipeline steps are in sequence. So I'm reading data from the CSV file which are stored in the GCS bucket and then format strings using my Purdue. And then as I told, right, we have to convert the data into beam row. So this is what this is a standard syntax or standard method to convert data into beam row. Then apply this SQL transformation. This is a SQL interface. So right, when we were discussing our concept, right, these are the two important concepts when you work with this Beam SQL, right? One is converting to row and then SQL transform interface. So Jetta SQL I'm using because I would like to write the data into BigQuery finally, right? So that's why I'm using Jetta SQL. This is a SQL dialect. And then in order to write the data into BigQuery, we'll have to convert the data into dictionary or JSON format. So that's where BigQuery reads the data, right? So then write the data into BigQuery table, right? This is my table name. So this table doesn't exist already in the project, then it will create. So before writing, it will truncate the data, then it will write, right? This is my dataset which is already available, right? So yeah, this is a code for this pipeline in detail, right? Now let us go to the demo, right? Let me try to submit my pipeline, right, using here it is already available, I guess, right? So this is a pipeline submission commands or code, right? Here it reads data from the GCS bucket. This is an if you have to write something into GCS bucket, this is defaulted to this part. But in our case, in this particular demo, we are not going to use this particular output. So we're trying to write data to BigQuery project and trying to submit my Dataflow job in Asia South to region in the staging location tempo runner Dataflow runner and save main session true, right? So this is one of the important input arguments where it will save your main session to if you don't want to lose any uh, right variables, right, environment variables, so you will have to use this, right? Okay, then let me submit this. Okay, right, now my pipeline started running. Okay, let me go to my Dataflow window. Let me go to my project, demo project, right, Dataflow. Still job not yet submitted. It will take some time to check if any worker available in this region, then it will submit. the job. Here you have to understand one more concept. Whenever you use Beam SQL, right, in the background, right, it will be converted into Java transformations, right? That's where you can see it's using internally Java SDK convert our SQL transformation into Java transformation. That's where it's trying to download the jar, and then it'll take some time to initiate that, right? Okay. Let me refresh. Meanwhile, let us try to examine our dataset if it is already available in our project. All right. This is my project. Yes, I have my dataset available. I don't have any table created. Once that pipeline runs successfully, you can see that table is getting created over here. You can see that, right? So still it is taking time. Yeah, you can see now jar is downloaded. Now it's time to submit our job. Just refresh it. Now you can see job is submitted. Okay, you can see the graphical representation of our job. It will take some time. Maybe when I tested this before, it took around 6 minutes I saw. So maybe take some time, right, to spin up workers, and then it has to submit the job to the worker, and then it takes some time complete, right? So here it is the job information. It's bad job running region. Okay, worker location. This is the zone where this worker is available in Google Cloud Platform. Okay, it's hardware information of the worker. Okay, and then it's a Dataflow runner. Okay, and just whenever this job is running, just try to observe the logs also. Here we have the logs, that is logging module is completely integrated with this data flow, so you can see how this is going on. Whatever you can observe here, you can observe here as well, right? If there are any errors popping up, definitely you can check this just by filtering if it is error, alert, or information, right? You can just debug that, right? So this is one. And here for jobs view, there are two views available. One is table view like this, and one is graph view. But I prefer graph view because it's more interactive and more user friendly. That's what I feel. This is my opinion. Okay, so I use graph view. Okay, okay, and then uh, let's see. It will take some time, definitely. Uh, uh, Meanwhile, we'll try to explore few other things in Dataflow. All right. So go to the jobs. Right here, this is one of the interesting thing, right? Dataflow also providing this feature where it's providing few templates for some standard use cases, right? Let us try to understand this, right? What do you mean by template? So there is already a template has been created for you to use it to perform certain uh, data processing task, right? So let us let this regional endpoint be used central, and try to see what are the different templates available. Let's see. So these are the different templates available. That means you don't have to code anything, you don't have to create any pipeline, right? You can directly, if you have this type of use case, you can directly come over here and use this template to process the data, right? For example, data stream to BigQuery. If you have to stream data to BigQuery, you can use this template, right? Data stream to Cloud Spanner, right? Kafka to BigQuery, PubSub, like that. There are many templates available, like right, Google Cloud Storage to BigQuery, BigQuery to Google Cloud Storage, right? JDBC to PubSub, text file to cloud storage to BigQuery. So like that, right, there are many templates available, readily written code. You can directly come over here and you can use that, right? You don't have to write any code. But only thing is, you have so many transformation to be applied on top of your source data, then we may not, and this particular template may not be that much useful. In that case, definitely you can write your own code, right? That, right, you can create your own pipeline using any of the SDK available, like Java, Python SDK, or Beam SQL, right? Go. There are many programs, right? This is one of the interesting things I would like to show, right? So this is a template. We'll see in upcoming videos. I will try to uh, show demo how to use templates and how to create data processing, right, using those templates. Okay, still it is taking time, maybe it will take some time, right? Okay, still running. Okay, and also meanwhile, right, so we'll try to see. I haven't shown you that this is bucket, right, where our input data available, right? So storage. This is the bucket. You can see this is the data, right? Right. This is the data. Yeah, it has, by default it is getting open up in uh, sheet, right? This is the input data. Okay. Okay, let us see. This is still running. Still running. 6 minutes. Yeah, now you can see. Earlier it was light green color. Whenever it runs successfully, it will become complete green, dark green. See, and one more thing, observe in the core, right? I have labeled each and every transformation, right? Formatted rows. What are the labels I have mentioned here? You can see those labels represented in a graphical format, right? Read formatted strings, convert as rows, group sum, convert to table, write to BigQuery. Now let us go to our BigQuery and try to see if this particular table is created, right? Batch data, and it should have the resultant data. Okay, let me quickly go there. See here. Now you can see batch data table has been created by the pipeline. Just preview it. You can see which is group cleansed, right, and transfer. You can use Beam SQL for creating pipelines. Thank you very much.